Thor Bjarnason with imaginginformatics.ca, and I'm going to discuss our open source project, AnalyzeNNLS. AnalyzeNNLS is built on MATLAB, so it's cross-platform and can be used anywhere MATLAB can be used. So you can run AnalyzeNNLS, and it opens up this main window shown here. And at this stage, there's only two things you can do. You can only load a new file or load previously analyzed data. So first, we'll load a file. I'm going to load a single slice quantitative T2 file. So this is a multi-echo acquisition with 32 echoes, which are shown under the view options. You can change the echo numbers and scroll through them. There's only one slice, so you can't scroll through the slices. At this stage, you can load an ROI, a new ROI, create a new ROI. You can window level or zoom in. So an example of window and leveling uses MATLAB's built-in window level function. And you can see it changes in real time. Also, you can zoom in. There's different types of ways you can zoom in. You can just draw a box of any size, or you can click to zoom in, and it does keeps your aspect ratio when you do that. To turn the zoom off, you have to click zoom again, and now all the buttons become active. All the buttons you can use. So now we're going to draw a region of interest in the GNU of the corpus callosum. So you click your draw ROI button and you choose different control points. To close the ROI, you double click. And to show you're complete, you right click and you click create mask. Now the decay data is shown in a new panel in the upper right. So at this stage, another button's unveiled, which is your Save ROI button. So you can save ROI, and it sets a name here automatically for you, and you can change this name if you wish. But as you can see, I automatically put in the date, which can help people look at their data. When they come back later, they can kind of keep track of which data is which, just based on date alone. So sometimes the date is a good thing to keep in. Alright, we'll save that ROI for future recall. So I'll just draw a new region of interest. And so at this stage you can draw all of your regions of interest ahead of time if you're going to do analysis using a different program or something, and save your ROIs. But for reason of demonstration, I just wanted to draw a new ROI so I could load a previous ROI. As you can see, we made a new folder in here. And there's the ROI. The ROI appears back on the image. Alright, at this stage we can also do our analysis. And you do this by clicking Run NNLS. That pops up an NNLS fitting options panel. And from here you can change your smoothing parameters. You can choose between even and odd echoes. You can cut off your echoes if you only want to. If you find you're hitting the noise floor and you don't want to use half the echoes in that example, then you can choose your echo cutoff to toss out those last echoes. You can also change which echoes you start at for cases where there's really bad stimulated echoes at the beginning of your acquisition. The echo spacing is pulled out of the header, but there's some data types that are loaded in this program that do not have the echo spacing in it, so you can modify it there. The T2 min and T2 max are the values of the T2 basis used to create a T2 distribution, and you can modify those if you want. By default it's set to 1.5 times the first echo times 2 times the last echo. And the basis length you can change as well. Default is 120. Now if you're happy with your fitting parameters, you hit Fit Data. Now all your results pop up. So on the upper right, you've got the measured data along with the fit, and directly below that are your residuals. And below that is the resulting T2 distribution. So nice thing about this, I use MATLAB's actual plotting figures, because instead of designing my own new user interfaces, because you can pull these around, you can resize them, and you can save the data right from here if you wanted to save this T2 distribution for a presentation or something. You can save it as a FIG file or EPS or PDF or whatever image file you prefer. Alright, and then in the results panel, it pops in the lower left, it has the area fractions in geometric mean T2 times. You can choose the T2 values in that region, so between here it's from 0 to 40, and it gives you the area as well as the mean T2 in that region. You can modify these if you feel that you can use a different range, or perhaps you want to pull both peaks together, or maybe you want the entire T2 distribution. And the area fraction's 1, which is what you'd expect. Alright, now at this stage, we can save this data for future recall. Again, I put a default name in here. I like to preserve the date. And it's saved. So as you can see, single slice was the file I opened, and it created a new folder, and within that folder it created the region of interest file for future recall. And then when I hit save data, it created this new folder called AnalyzeNNLS data, and from that we've got our various results. From these results, all these CSV files in AnalyzeNNLS, they're all text files that you can read if you just drag that into a text editor. Or you can create a script to search through your analysis files in order to create statistics without entering everything into an Excel spreadsheet, for example. You can run a script in using something like Python or whatever to pull out all your results and do your statistics. Alright, so let's have a look at a different file. The first file I showed you was data that I collected as part of my master's work with University of British Columbia. It's a single slice mutliecho file, mutliecho image file created using a 1.5 GE scanner and using UBC's proprietary BFF format. This other file here is also collected from UBC. It's a PAR-REC format, and that's Philips file format. So this is collected on a 3.0 Tesla scanner. You see it took a little longer to load. It's 8 slice data. It's quite nice. And again, all the functionality that I showed previously is still there. You can change your window level, load ROIs at this point, zoom in, scroll through echoes again. So I'm going to draw another region of interest in the GNU of the corpus callosum. Again, I can save the region of interest at this point, but I'm just going to continue and run. There you go. So as you can see, same kind of procedure with your residuals on the right, your fit on the upper right, and the resulting T2 distribution in the bottom right. And your results panel pops up as well in the lower left. So at this point, again, I can save my data, but I think it's a little more informative to show what it looks like when I load the data I previously saved. And there we go, all the results pop back up as they were before. Region of interest is shown on the scan as well. So this was a brief tutorial on how to use AnalyzeNNLS, which is an open source project that was developed by the Imaging Informatics Lab. So if you want to download AnalyzeNNLS, just navigate to SourceForge and go to sourceforge.net/project/AnalyzeNNLS. And you can download a Mac version or a Windows version presently. And in the future there will be a Linux version as well. If you need to contact me, I'm Thor B. Arneson with imaginginformatics.ca, and the contact information can be found at this AnalyzeNNLS SourceForge site. Thank you for your attention.